We're mid-exams with one tomorrow and another next week, but we wanted to keep up momentum on the channel, so this is a quick video whilst we're working on the blinds actuators, and in answer to a few comments we've had about lighting.
Also, I will say, curtains are still here. That's because we found that they actually made a massive difference to the sound quality. When we took them down, they clearly dampen a lot of the echo. But anyway, different topic. Today we're going to look at addressable LEDs and understanding the basics of them. By the end of the video, we'll have covered everything you need to know to get started on them.
In fact, in our first ever video, we had addressable LEDs in the background, and they already installed around these black panels. Unfortunately, we blew up the Arduino that had the code on it because Arduino power supply regulator fried and pushing 12 volts on the 5 volt rail.
That was during the start of the Gantry robot project, which if you haven't seen, we'll put a card up in the corner up there now and have a look at that if that's the kind of thing you're interested in, this little Gantry robot here.
This video goes live on Saturday, and then the following Saturday we'll have an update for the blinds.
In the meantime, let's talk about LEDs. In construction, LEDs have become really common in kitchens and around the house as sort of under cabinet lighting. Over the last couple of years, they've become really popular sort of behind TVs, going behind furniture units, things like that. Addressable LEDs in construction itself, so from a building perspective, haven't really had widespread uptake because they require the microcontrollers and the programming, which is not the case for standard LED arrays. And I think I have some construction LED drivers. I've got two here. So these are the kind of things that would go into the house, and these take 240 volts mains down to 12 volts for sort of kitchen lighting and things like that.
Any colour changing built into these tend to be hard coded or specific colours already built in. You can buy lighting systems for behind the TV or whatever, and that's fine, but we really like the idea of creating something that has function as well as form.
Yeah, and I think function as well as form is the important bit, and in a future video we want to look at light arrays with addressable LEDs as a form of feedback. For instance, you could have an array of light bars to tell you the temperature, humidity and CO2 level in a room, which we've discussed in previous videos.
For this video though, we are just going to look at the LEDs themselves and getting them up and running. Timestamps on the screen now.
So we'll look at the simplest of simple wiring and then programming on an Arduino. In the future we'll also look at other control methods.
After that, we will talk a bit about colour theory. Then we will talk about some interesting uses for addressable LEDs.
Then we're going to go through some common faults and issues to hopefully preemptively solve any problems you might have. We had a few when we were playing with these.
Finally, we'll look at some examples of functions that we can use to make different lighting effects.
So, let's get into it.
Okay,
so we're going to talk about addressable LEDs, and we've got a few different types here. We've got three different versions of basically the same thing. These are 30 LEDs per meter, IP30, which is a standard, and I mean these are identical to the other two. There's just less of them per meter. You can see that here, like so. So, in terms of color intensity, these ones will be brighter and sort of more obviously colored. We'll put these to one side. These are IP30, 60 LEDs per meter, addressable LEDs, and these are the same 60 LEDs per meter, but these are IP67, which means they're water resistant, I think, rather than waterproof, which is why they're in this rubber casing. I ordered these first, and then I ended up going back and ordering these because for what I need to do with them, which is to put them behind the board of our sort of backboard, our development board, these come with the adhesive strip on the back, and these ones don't. Anyway, I'm getting a bit sidetracked here. Addressable LEDs come with connectors on each end. Red is power, white is ground, and then green is signal. And the connectors on this end, these are just doubled up. So you've got a white and a white, one for sort of jumper cables and then one for if you're hardwiring it into something. I'm not quite sure why there isn't a hardwired signal cable. That would make sense to me. But anyway, we're going to get into the wiring of this. So to wire up these addressable LEDs, we're going to start by just taking our power and connecting that directly to the 5 volt supply of the Arduino, which is, I think, that there. Then we can take our ground connect that directly to our ground of our Arduino, like so, and then our signal, and we're going to connect that directly to pin 7. And that is the simplest of simple wiring that you can do for addressable LEDs. There will be some comments that will say, well, hold on a sec, that's too much current draw for an Arduino. The way these addressable LEDs work is they strobe. So whilst it looks like they're all on to the naked eye, if you take a high-speed recording and slow it right down, you'll see that they're actually blinking. This is the same way that sort of 50 Hertz household lights work, and this means that this Arduino is actually capable of pushing power to these fairly reliably, and we'll show you that in a minute. Obviously, if you're wiring them into something permanently, then by all means set up a separate power supply, and we will probably do that as well. But in terms of testing and playing and just getting going, this is totally fine for a starting point. And Ethan's going to jump into some of the really, really basic coding, and we'll do that now.
And now onto the code. So there's a couple of things you need to do first. Select what data pin you are on, how many LEDs are in your strip, and how bright you want the LEDs to be. Secondly, to set the colours, it's not as simple as just putting in the values. You need to create your strip object and give it the number of LEDs, the LED pin, and the LED type. Now there's a couple of types of addressable LEDs. We have a WS2812 strip. Colours are stored in unsigned 32-bit integers. The way you create them is by doing strip.color and selecting the R, G and B values. To set it up, all this does is sets up the strip, sets the brightness and shows. If I run this code, you'll see that nothing turns on, and that's because we're telling it to show nothing. It's important to note that if you edit any of the pixels, you need to call strip.show to show the results, otherwise they won't update. I have created just a couple of basic colours just to show you. So here, let's just set it to blue, and if I run this code now, you'll see that the strip turns blue. Now I can change this to only use 50 of them. However, because of the way that these strips work, they almost remember their state. What needs to happen, if you just create a clear colour, you can clear all of them. And if I just run 50, you'll see now, when I run this, the ones we're telling to go blue have gone blue, but the rest has remembered their state. And I can show you this by changing this to red. You can see now that some of them have gone red, but the other 270 have stayed blue. The way you can get it to kind of reset it is by unplugging it. I haven't quite found a better way yet, apart from clearing them and then reinitializing the object. But for now, we will just work with just 50 of them. There's some other things we can do. So for instance, instead of just filling the whole strip, you can iterate through each pixel color and set each pixel color. So if I put this to green and rerun this, we can see that it sets 50 of them green and then it goes red. You can make so many different functions and so many different combinations of changing the different colors that you want to add, changing the different amount of LEDs you add. It's all up to you, and that's the great thing about NeoPixel. In the future, we plan on using addressable LEDs not only just hard-coded, but also with components, be it with a potentiometer or a force sensor, or integrating it with our previous projects such as the gantry robot, or the home temperature sensing, or even the blinds potentially, but that might be counterintuitive. At the end of this video, we're going to go over some functions that we've made to show it to do different things. However, for now, we're going to move on and start talking about colour theory and how these can be used.
There are loads of online resources for colour theory and combinations, and I will put a few links in the description below. But when it comes to computing, we typically work in 3 channels: red, green and blue. And a lot of our current colour theory and colour imagery is built on that logic. This becomes more obvious when you see it, and the first experiments with colour photography were done with coloured filters over the lens of a camera. That's kind of how a colour camera works. It actually records 3 separate images and overlays them onto one another. An early example of this is with this image taken in 1911 of Muhammad Alim Khan, the Emir of Bukhara, by Sergei Prokudin-Gorsky, using 3 exposures with blue, green and red filters, and we can work out which filter is which just by looking at the images. You can see here that the main colour of this sort of overcoat is blue, and this channel would therefore be the blue channel because it has the highest intensity of blue, which is shown here as white. This would be the green channel because you can just about pick out some green on his coat here, and this would be the red channel because you can see that the red strips around the edge of the coat are shown quite light in this image. White always shows up as white because it's intensity in all colours, and black subsequently always shows up as black because it's basically a 0 value for all colours. The first ever colour photograph was taken in 1861 by a man called Thomas Sutton using the same method, and created this hauntingly beautiful picture. I believe this is a multicoloured or tartan ribbon, and was used to demonstrate the theory of overlaying different filters to produce depth of colour. And that brings us on to the next section, which is colour mixing. What we want to do is look at how different wavelengths of light work together to create different colours, and there are 3 base colours we use: red, green and blue, each with a range of values between 0 and 255 for their intensity, theoretically giving us over 16 million individual colour combinations. So when everything is set to 0, our strip is not lit. This is essentially saying black. And when we set everything to 255, we get max intensity for every colour channel, and that gives us white. And if we want red, it's just the first number, because this is a red, green, blue channel. If we want blue, it would be just the last number. And if we want any combination, say purple or magenta, we can change red and blue up. Or cyan, where we have no red value, but we have maximum green value. And importantly, with this, we have a range of values that we can iterate through, which leads us on to the next chapter of this video.
We already touched on this in the introduction, where we mentioned the idea of having these set up as warning light arrays, or at least indicators, and you could set that up in quite a fun way.
One example was if you were to map the colour range between cyan and orange to 0 and 25 degrees, you could use it as a visual thermometer for the temperature outside.
We could map the intensity of the blue light from an LED strip to show humidity in a room, or a simple white light along the length of an LED strip to show the CO2 level.
One thing I would like to do is have an LED strip on a hydroponic setup with a live readout and subsequent colour code for the pH of the solution. Seeing as pH is a visual measure anyway between red and blue, with green meaning sort of neutral, that would be a really, really neat function.
We could also look at connecting them up to a microphone so that the colour intensity of a backlight changes with the volume, or even go further than that, map the pitch of the sound to different light channels.
And we'd love to go into some of the functional applications for this, and intend to in the future, but for now we're just going to talk about common faults. With all electronics projects, the thing that we get the most wrong the most often is common grounds. If you don't have a common ground, you will have totally wacky errors. And we've set these LEDs up with an external power supply to just show you what that looks like. So the code for these is just passing one colour, which is the cyan, the blue, and with no strobing or filtering or anything like that. But you can see that the LEDs are going just flickering or changing colour, and that's basically because of noise differences between the signal line and the power line. So if we put a common ground in, it normalizes the baseline voltage and will essentially remove this noise. So we'll do that now. As soon as we add the common ground, they become stable. If we take it away, they start to change again. And as soon as we add the common ground again, they become stable. So that's always the first thing to check.
As you can see here, it's the same setup as before, but here we're powering it and we're supplying the data from the other side, and as you can see, nothing is on. And this is because data flows one way through this strip, indicated by the little arrows here. It's a very small arrow and easy to miss. I'm going to connect everything on the correct way. Like so.
So one thing you do get when you up the number of LEDs that you're powering, so here we're powering now the whole strip, 320 LEDs, with just the power supply on one end, and it's just a 5-volt power supply. So these are all at 150 sort of in each channel, and we're getting a decent whitish light at one end, but it drops to yellow at the other, and that's purely because of voltage drop. And one way we can rectify that is to power it from both ends. So if we put another ground in and another power supply in, and I'll take the power from the Arduino this time, you can immediately see that the colour becomes more normal. There is still some yellowing in the middle, but 320 LEDs is quite a lot to power just from sort of one Arduino. And you see this most with white if you're doing any other colour, because it's less overall power, because you're powering fewer overall channels. You basically have less of an issue with voltage drop. This primarily applies to white. If you were to convert all of these to red, you wouldn't have this same problem. In fact, if I unplug this end, Ethan, can you put them all to red, please? You can see we have no real issue with voltage drop, because we've gone from 150, 150, 150 to 5500. So, something to be aware of if you're using white lights.
Another fault is that you're using either an incorrect library or you're not using an up-to-date one. So if you just search addressable LED, there are tons and tons of libraries that work with addressable LEDs. However, you need to find a library that works with your addressable LED strip. Here we're using NeoPixel because it supports the WS2812. So with everything wired and coded, we have reinstated the LEDs on our dev board behind us. You can obviously see them working. We will change the functions that is going through and overlay the code above. So if you like the look of anything you see, then by all means pause the video and copy down the code.
We've done wiring, code, colour theory and debugging, and that's kind of all we've got time for. We have an exam tomorrow morning and still have to do all of the editing for this video, but if you came looking for LEDs and how to use them, we hope this has been helpful.
If you're watching for the same reason we are recording, which is procrastinating revision for our exam tomorrow, good luck. We hope it goes well.
And if you're watching because you've been following our projects, then please know we really appreciate your support. We like to hear from you. Let us know what you think, let us know what projects you have in mind, and let us know if you have any other ideas for functions for the addressable LEDs. One final one we didn't mention earlier was as a kind of nightlight, combining a PIR and an ultrasonic to detect movement in a hallway with the range and then light up the appropriate part of the hallway.
That could be quite freaky. Ghosts. That's probably a whole other project in itself. Next week, we'll hopefully finish off the blinds. We had to do a second iteration of the pulley, as the first one was ever so slightly too small on the stepper rotor. So check back in with us next week for that. Thanks again for watching. We really appreciate all the support, the comments and the accountability. We'll catch you soon.
Bye for now.